Good morning, my dear students. So today's topic is Lagrange's mean value theorem. So in the last class we have discussed about Roche's theorems, and now the discussion of the today's topic is Lagrange's mean value theorem. First, what is the statement of this theorem? First, the function f is a function defined in a closed interval ab and which is a real valued function. Satisfying the condition is that it is continuous in the closed interval ab and it is differentiable in the open interval ab. These two conditions. But in Roche's theorem, there is another condition was that is fa and fb are what? Same. Here fa and fb may not be same. May not be what? Same. So there is a general cases, not so you can say Roche's theorem is a particular case of Lagrange's mean value theorem. Other two conditions are same, such that difference. So there exists some c belongs to what? AB, such that f dash c means slope of the tangent at the point C. F dash c equal to what? FB minus FA divided by B minus A. Here you see, if FA and FB are same, then what will be happen? It will be 0, and finally you are getting what? 0, and it becomes your Roche's theorem. So Roche's theorem is a particular case of Lagrange's mean value theorem. Now what is actually this mean? ये क्या चीज़ है पहले पता करना है. Before going to this, just I remind you a concept that is called, suppose this is a line joining the point x1 y1, another point is x2 y2. Okay, this is the point, this is the line, suppose AB. What is the slope of the line? Slope of the line MAB. Slope of this particular line MAB is equal to what? We know y2 minus y1 divided by x2 minus x1. Okay, we know that slope of a line joining two points is given by what? y2 minus y1 divided by x2 minus x1. Now go to the figure, you will see that is your function. This is your what? Function, and define in the closed interval what? AB. Here FA, this is your FA, and this is your FB. FA not equal to what? FB. This is not given. In case what is an FA and F, there is no condition that is FA is equal to FB. It means FA not equal to FB here. So for x is equal to A, what is y coordinate? FA. That means the point on the curve is what? A, FA. And for B, when x is equal to B, y coordinate is what? FB. And the point on the curve is what? B. And if you join this, you are getting a what? This is your curve, right? This is your curve, and this is the chord of the curve. You can say it is a secant of the curve. Okay, and this secant or chord are joining two points A and B. So definitely, what is the slope of this AB chord? Slope of the chord AB will be, by using this formula, you will get y2 means what? This coordinate, and y1 means what? This one. That means y2 minus y1. That means you are getting FB minus FA divided by x2 minus x1, means B minus A. That means this representing, this particular term representing what? Slope of the chord. Slope of the chord. And this is representing what? F dash C representing what? The slope of the tangent. As per our geometrical interpretation of F dash S, slope of the tangent at the point what? C. And what is C? C is a point lying between what? A and B. So this is the point C. On that point, for particular C, there is a corresponding y coordinate C FC, and this is the point C comma FC. C comma FC, where you can draw a tangent, and this tangent is what? Parallel to what? The chord. Both the slope are same. This is the slope of the tangent. This is the slope of the chord. And since both are equal, means tangent is parallel to the chord. This is the geometrical interpretation of Lagrange's mean value theorem. Lagrange's mean value theorem, it is defined on a closed interval AB, which is a real valued function satisfying the condition that fx is continuous in closed interval AB, fx is differentiable in an AB. Then there must exist at least one point C between A and B, such that f dash C equal to 0, means that is slope the tangent is equal to slope the chord, means the tangent is parallel to the chord. there will be one tangent. If there is a one point, there will be one tangent parallel to the chord, or if there are more points, see maybe more than one, then there will be more tangents parallel to what chord. In this particular figure, you see there is a one point, and in this particular curve, you see FA not equal to FB. This is the chord, and this is the coordinate of the point A comma FA, and this is the point B comma FB, and then slope of the chord will be given by this. And you see from the figure, this is a particular point C1. For corresponding C1, there is a coordinate FC1, and you are getting a point on the curve where tangent is parallel to this chord. You are getting another point C2. For this another C2, you will get what FC2, and there is a point on the curve C comma C2 comma FC2 where tangent is parallel to the chord. Here another tangent is parallel to the chord. So there are 3 points C1, C2, C3 within this interval AB, open interval AB, where tangent are parallel to what? The chord. This is the geometrical interpretation of what? That is Lagrange's mean value theorem. So let us solve 1-2 questions related to this particular mean value theorem, then your conception will be more clear. Question: verify Lagrange's mean value theorem for the function fx is equal to x square plus 1 on this interval 1, 2. On this interval what? 1, 2. First you find f dash x. It is required. F dash x is equal to twice x. F dash x is equal to twice x, and this f dash x for every value between the open interval 1 and 2. You see f dash 1 equal to 2. There is a for every point there will be a unique value of f dash x. Okay, between this interval 1 2. Okay, whatever be the points are there, for every point f dash x takes unique value, and therefore we can say that f dash x exists. So therefore we can say that fx is differentiable in open interval 1 2 and continuous in closed interval 1 2. Continuous, why? Because it is a polynomial function, and we know the polynomial function are always continuous. So both the condition of LMVT is satisfied. Okay, therefore and also you see f1 is not equal to what? F1 is equal to what? 1, and f2 equal to what? There is 5. So it is not satisfy the condition of Rolle's theorem. So you have to apply mean value theorem here with Lagrange's mean value theorem, LMVT. Okay, therefore there exists some C belongs to the open interval 1 2 such that f dash C equal to what? FB. According to the definition FB, FB means what? F2 minus FA means what? F1 divided by B minus 1 means 2 minus 1, which is equal to what? F2 minus F1. What is F2 actually? F2 equal to what? By replacing x by 2, you are getting what? Replacing x by 2, what you get? F2 equal to what? 2 square plus 1, that is 5. It is equal to what? 5. And F1 equal to what? 2. Finally you are getting what? 3. Now what is your f dash x? F dash x is equal to what? Twice x. So what will be f dash c? Replacing x by c. Replacing x by c, you will get f dash c equal to what? Twice c. So your f dash c equal to what? 3. So you write twice c equal to what? 3, and finally c equal to what? 3 by 2 is 1.5, and 1.5 definitely lying in this open interval. Therefore, Lagrange's mean value theorem is verified. Lagrange's mean value theorem is verified. So in this way you can apply. Sometimes question will be asked. In this question you can define the question in this manner that find the point on the curve where the tangent is parallel to the chord by using Lagrange's mean value theorems. So you have to do like that, and finally when you get c equal to 3 by 2, it is the x coordinate. Okay, so corresponding y coordinate you have to find, and you will get what is the corresponding y coordinate is 3 by 2, 9 by 2 plus 1 is equal to what? 11 by 2, and that is this is the y coordinate, this is the x coordinate. That means 3 by 2 comma 11 by 2 is a point on the particular curve where tangent is what? Parallel to the chord. Tangent is what? Parallel to the chord. So you can add this, then your answer will be fulfilled. So I hope you understand. Thank you very much. Thank you. And I believe that I have completed this chapter, and if any doubts you have, then you can ask the doubt. Also, in the next chapter I will start with the application of derivative. It is also a part of the application of derivative, because using differentiations, how to use the rules theorems and Lagrange's mean value theorem. These are also one of the part of application of derivatives. So next class we will directly start with the application of derivative chapter. Thank you very much.